So I'm actually a container and DevOps nerd. Funnily enough, I'm not a storage nerd. So I'm going to be talking about data management in Kubernetes with Portworx. And just a little bit of background on me. So I'm what we're calling legacy Portworx at Pure Storage. Although I keep getting told off for saying legacy, so I think I might go with maybe vintage Portworx. I was at Portworx for a couple of years before the acquisition, and my background is as I said, in DevOps and working in various software vendors. So the agenda for my session, I'm going to start off talking a little bit around challenges in relation to Kubernetes and really where we are from a maturity perspective. Then take a look at Portworx and how it addresses some of those challenges. I'm going to jump into the architecture and kind of give you that initial kind of foundation of how Portworx works before going into a bit of a demonstration around one of the capabilities that's really growing in popularity across the EMEA region, which is where I'm based. And then at the end of my segment, I'm going to hand over to Gu, who is a tech field day veteran, and he's gonna take you through a deeper dive into the Portworx architecture. So just to give you a little bit of context, I want to start by talking about my experience in the field working with customers, and that's very much my role, right? I spend a lot of time on calls these days, not so much face to face, but I used to spend a lot of time traveling around the region, really learning about how containers are being used and how Kubernetes is being used. And I want to kind of share that experience in relation to what I think is quite interesting data that comes from the Cloud Native Compute Foundation's Kubernetes Adoption Survey. And I've been looking at this data over a number of years, and it very much sort of aligns with what I'm seeing at the coalface. Now, not to disregard complexity or cultural changes as a challenge, but if we focus in on the sort of technical elements here, we can see that security and storage and monitoring were listed as the kind of the top three technology challenges by the respondents. And as I said, I've been looking at this data for a number of years, and storage is really kind of moving up the ranks, so to speak. And it's in last year's survey that it came up into second place. And I think it really reflects where we are when it comes to Kubernetes adoption. From my view, we're kind of near the top of the bell curve in terms of maturity at that sort of vendor proliferation stage. And that really matches with the maturity of the customers I'm engaging with. And what I'm seeing is that now really the criticality of the workloads that are being containerized and running Kubernetes is increasing. Now it's those kind of critical enterprise workloads that are maybe part of sort of core banking applications. And as that criticality increases, we're seeing a massive growth around the need for storage and data management for essentially managing state, which is really, that makes up the majority of those enterprise apps. The majority are stateful. And what we tend to see is that there's this assumption, and this kind of, again, is coming directly from the organizations I'm engaging with. There's this assumption that traditional storage is suitable for providing a persistence layer or some kind of storage solution to a Kubernetes-based platform. But unfortunately, these systems are sort of fundamentally not designed to support the dynamism, the portability, the granularity, the application centricity of container-based environments, especially for critical workloads. And to give you some examples, if we think about how Kubernetes handles a server failure, it redeploys all the workloads onto other nodes. When you introduce state, you're then depending on infrastructure automation behind the scenes, which is often slow and fragile and starts to degrade the value that Kubernetes gives us at that orchestration layer. We also see that containers are a catalyst for hybrid cloud. The portability that containers give us helps to accelerate those programs. But again, when you introduce machine-centric or traditional storage, it's almost like an anchor, and again starts to impact that portability. I'm going to focus in on disaster recovery when I jump into the lab in a minute. But it seems like we've solved that problem when you look at it from a machine perspective, right? We know how to replicate data. We've been doing it for quite a long time. But when we start to look at Kubernetes and multiple clusters, maintaining the mapping between application config and volumes is incredibly important to be able to actually fail over. And again, that's a massive limitation. And I think increasingly, going back to my point around maturity, this idea of supporting multi-tenant environments and introducing more stringent security controls, again, becomes very challenging when you have heterogeneous environments. How do you control encryption across potentially multiple storage backends and infrastructure environments? So just to switch the focus now to Portworx, now when it comes to sort of the design behind the solution, we've taken a lot and learnt a lot from a perfect example of a distributed, orchestrated, scale-up platform, and that is Kubernetes itself. So we've almost used that as a blueprint for designing a lot of the capability within Portworx. And if I look at some of the kind of key attributes of Kubernetes, things like the fact it's multi-cloud, it's infrastructure agnostic, and gives you that consistent control plane over any infrastructure backend, makes it an incredibly powerful tool, right? The fact that it operates at massive scale across thousands of nodes, supporting tens of thousands of pods, like achieving really huge density on the infrastructure on which it's running. And finally, again, that idea of that consistent control plane, almost allowing immutability when you start to control deployments, purely from, let's say, a Git-based pipeline. Having that consistency wherever you're running your Kubernetes is really allowing that new way of working, a new way of building software. So to jump into Portworx, so we've really used a lot of those design principles and that blueprint in the design of the product. And ultimately, Portworx is a software-defined storage overlay that's been built specifically for Kubernetes and cloud-native use cases. So Portworx deploys via the usual methods that you may be familiar with in Kubernetes, which is via an operator or a Helm chart or a daemon set into any Kubernetes cluster, just like any other Kubernetes component. So if you've had any experience with network drivers, for example, you can almost think about Portworx as an infrastructure component that you would have, that you would manage and deploy in a similar way. Once Portworx is running, it's then provisioned. So our storage, which I'll explain more in a moment, is provisioned using the existing storage primitives within Kubernetes, now increasingly commonly with CSI, and we do that with storage classes and PVCs, which are those kind of native kind of methods for provisioning storage within Kubernetes. Now, I was talking about agnosticism on the last slide, and just like Kubernetes, Portworx is completely agnostic at the platform level. So any Kubernetes distribution, the infrastructure layer. So we run essentially in any infrastructure environment, whether it's virtual, physical, or cloud, but also for storage. And again, I'll go into the architecture in more detail in a moment, but we will run on top of any underlying block storage subsystem. So our primary purpose is to provide resilient, performant, secure, persistent block and file container volumes for storing application data or stateful application data within a Kubernetes environment. And uniquely, and for me, what I think is probably really the most exciting part of Portworx, and this is the kind of feedback I get as well when we're running those kind of POCs and lab environments, is the fact that it's really focused on applications, meaning that it understands things like topology. It can adapt to suit. We can adapt its data path really to suit the kind of stateful application that's being run and is using Portworx storage. It does things like maintaining consistency across clouds and regions, and it can interact with an application when taking a snapshot. And that's really unique in this space, that focus on the application workloads and adapting to suit the needs. So before I jump into the architecture, from this deployed Portworx environment, you can see we've got a set of capabilities there, which I just want to quickly explain to you. My colleague Gu is going to go into all of this in more detail, but we have our core storage engine, which is the thing that handles all of our container volume replication. It really is, understands topology, takes application consistent snapshots. That's essentially our data path. And then looking at the rest of the capabilities, they're really focused on data protection. So the backup capability gives us that offsite backup of not just the volumes, but the objects within Kubernetes, right? And that goes back to my point about disaster recovery earlier, and the importance of maintaining that link or that relationship between those two things. DR, I'm going to focus in on in a moment. Migration, all about cluster to cluster portability. The abstraction that Portworx brings over traditional storage really makes data as portable as the containers, and the migration tool enables that. And then on the security side, we're offering access control and encryption capabilities. And then finally, with Autopilot, this is essentially a rules engine for policy-driven management of Portworx. So again, really aligning with that GitOps approach to managing an environment.
You talk, Portworx is completely agnostic. Is there any difference, though, in particularly looking at that some of your competitors' storage at any infrastructure level? Is there any difference in capability depending on platform?
No, I mean, so within Kubernetes, no, right? And I'm talking a lot about Kubernetes because it's sort of the dominant scheduler, right? But when it comes to different flavors of Kubernetes, no. If you're running in Swarm or some other schedulers, there are slightly different capabilities. But no, in Kubernetes, it's the same.
You skillfully avoided the storage question there, though. Any difference in storage vendors?
Yeah, so look, on the storage vendor side, if we're talking about, let's say, traditional storage vendors, so let's say array vendors, for example, most of their integrations with Kubernetes are tied directly to their storage systems, right? And that's kind of one of the advantages that we have there, is that you can run us on top of anything, including our competitors' block storage, right? Other solutions on the cloud native side, so we're the most mature from an enterprise perspective, right? From a feature set perspective, we're quite clearly ahead of other options.
And one last question from me. Honestly, it's not just because I'm trying to do a Brit takeover of the day, but do I understand this correctly? So what Portworx allows me to do is orchestrate the entire movement of the container, including its data, across any of these kind of infrastructure elements. So we're kind of picking it up in its entirety and having the capability to automate its kind of movement across whatever infrastructure you have available. Is that right?
Essentially, yes. Yeah. I mean, obviously, there's more to it, but yeah, that's essentially it. I mean, a good analogy is that Kubernetes orchestrates applications in containers and pods. We orchestrate application data in container volumes. And in the same way that you can run a container in essentially any Kubernetes, we will also orchestrate the process of moving those application workloads with our virtual volumes between those environments too. So yeah, it's a powerful tool, especially when you get into multi-cluster. Yeah.
That's great. Thanks, Joe. Appreciate that.
Sure. Anything else before I move on? All right. So I'm just going to switch to a slightly different screen. So just give me one moment to do that. So look, I'm not going to go super deep into the architecture, but I want to give you sort of a bit of a foundational kind of understanding of that. As I said, Gu is going to go deep into this and explain kind of what's going on behind the scenes. But just from an architecture perspective, if we take a common Kubernetes cluster, so let's say we've got 3 worker machines here where our containers and our pods are getting deployed. This is essentially our kind of Kubernetes layer. Right now, as I've said, these can be anything. These can be virtual, physical, cloud. We don't care, right? Now, Portworx, as I've said, needs some kind of underlying storage to run on top of. And again, that can be anything as long as it's block. So, we have customers who run us in like an environment backed by arrays. Of course, we support virtual environments. So this could be a VMDK. It could be something in the cloud like EBS, managed disk. As long as it looks like an attached block device, we can use it. Right now, actually, just to add to that, in some environments, we can actually go off and deploy these underlying storage devices, which just starts to kind of play into that automation story around using something like a Terraform to bring up your cluster and have Portworx go off and provision the storage, and also manage the capacity. Now, as I've said, Portworx deploys into this environment with an operator or a Helm chart or just a nice big long YAML file. But ultimately, what you end up with is a Portworx pod running on each of these workers. There are other components, but as part of the installation, we're going to go off and scan for any attached block storage devices. And then that's what we form our storage pool from. We essentially pool and aggregate those devices. So then from a developer perspective or a user of this environment, I'm going to deploy, let's say, a Postgres. There we go. Happy. Deploying a Postgres into that environment. Now we need to store the data somewhere, so they're going to use a storage class that's using Portworx as the provisioner, and that's going to go off and provision a Portworx volume with a file system on it, which is essentially a virtual block device, which appears to the host as direct attached storage. So the file system on this virtual block device, what should be attached there, is going to be mounted at var lib data, whatever the path is that you've specified in the deployment mechanism for that containerized workload. So that's the kind of core of what Portworx is doing. Now, there's a load of stuff around that from a capability perspective, such as replication that we can do. So, for example, you might set a replication factor on this volume, and over the host interface, Portworx is going to go off and make sure that this volume is synchronously replicated somewhere else in the cluster, right? And the reason that we would do that is because things break, as you all know very well, and we want to make sure that we can recover our data and continue operating our stateful workloads. And in this particular example, I've mentioned Portworx's understanding of topology, and what that means is that we're almost adding sort of data awareness to the Kubernetes scheduler, meaning that if we do have a failure of some kind, whether it's networking based, storage based, whatever, when Kubernetes says I have to redeploy here or here, we can get involved in that decision and say, you should run the pod there because that's where your local copy resides. Now, this example is a single pod and a single volume, but as we know, Kubernetes operates at massive scale. And so that kind of intelligence remains highly performant. This happens very quickly. But for thousands of pods and thousands of volumes, right? It's essentially adding, as I said, that data orchestration capability.
Joe, you're saying that gets presented through as a block device and get mounted to a location.
Yeah.
What's the mechanism of replication then between those? Is that a block-based replication or files?
That's right. It's absolutely, it's block level replication. Yeah, and we implement a custom protocol on top of raw TCP.
And is that wait on write or asynchronous?
Synchronous. Yeah.
Okay.
It's crash consistent, essentially, is what you end up with.
Okay.
Cool. Any more questions on this, or if not, I can jump into the demo. Okay. So let's switch back over. So I want to focus in on the DR use case now. So you'll see here I'm talking about storage that understands applications, and hopefully that's kind of starting to come through from some of the things I've been talking about. But in EMEA, we see a lot of demand for disaster recovery, probably, I guess it's due to geographic reasons, right? Because we can run sort of metro clusters between like Zurich and Geneva because we have that low latency. And as I said, we already know how to do that with infrastructure. There's loads of ways that we can replicate data, but the big challenge is bringing back tens of thousands of containerized workloads and also making sure that you map them to the correct replicated volume. Now, one architecture that Portworx supports is this idea of a stretch cluster, where it can be stretched between two Kubernetes clusters, where we have latency under 10 milliseconds round trip between those environments. And not only will Portworx replicate the container volumes synchronously between the failure domains, we also synchronize all of the deployment config that was used to actually get those containerized workloads running. And we maintain that mapping between the container volume and the resource that's consuming it. And this allows us to automate recovery. So if a site goes down, because of our integration with Kubernetes, we can call out to the scheduler and essentially bring those pods back online and mount the correct volumes. And we do that very quickly. So in this sort of scenario, we can hit an RPO of 0, and an RTO it's always going to depend on the containerized app and how long it takes to come online. But we have customers who can achieve sort of under 2 minutes. What I'm going to run through with you in the Metro DR demonstration looks a little bit like this. So we're going to have the two Kubernetes clusters running, as I said. One's essentially active, one's standby. Portworx stretched between them, and I'm going to show you the concept of cluster domains, but it's synchronously replicating data. I'll show you the schedule we have for keeping the config in sync, and then we're going to simulate a failure. Well, not simulate, I'm going to destroy some servers, so we're actually going to make it fail. And then I'm going to go through that re-establishing quorum process and triggering a failover in the second site. Okay, so let's get into it. So here we have, let's clear that. So I've got a couple of Kubernetes clusters here. Each one, it has a single control plane node and 3 worker nodes, same in the bottom. And they're completely separate Kubernetes clusters, right? Apart from Portworx, there's no relationship between them. But if we take a look at Portworx, we can see it's running in this cluster, and you can see we've got these 3 Portworx pods, just like my architecture diagram, and it's running on each of the 3 worker nodes. Now, that's true in the second cluster as well, but if we talk to the Portworx API and say, describe yourself, you'll see it has 6 nodes. So that's the stretch cluster that I was talking about, right? Kubernetes sees 3, Portworx sees all 6 across the 2 clusters. Now we've also defined here something called a cluster domain, and the name of the Portworx installation is Metro cluster, but we have these 2 cluster domains. So in cluster 1, I've told all the Portworx pods you're in cluster 1, and in cluster 2, I've done the same. And that's what Portworx is using to understand where to place volume replicas, right? So when I provision a replicated volume, we're going to make sure that the replica resides in the second failure domain. Now, I also have a migration running, and the migration is purely for the application config. So I do have a Cassandra cluster already running. You can see I've got 3 pods and 3 volumes. These are Portworx volumes, and I'll show you a bit more on that in a second. But I've got a little migration script running in the background. This is built into Portworx, and you can see, let me zoom out a bit. You can see it's successful, which basically means that it's every few minutes it's successfully copying across any of the objects that I create in the Cassandra namespace or any other namespace that I might include. So if we jump into the second cluster, if I get namespaces, there's Cassandra. I didn't create that, right? Portworx has done that as part of this migration schedule. But if we check pods, it's empty. And that's because it's on standby, right? So there's nothing running there, but the object that controls the pods does exist. The stateful set, which is a deployment type, that exists, but you can see it's scaled down. So it's basically waiting for me to tell it to activate when a failure occurs. So hopefully that's clear. That's the setup I've got. Now, if we list the volumes that I've created with Portworx, we can see we've got these PVCs used by each of my Cassandra instances. And if we just inspect that, we'll see, okay, it's replicated on both sides. So this is cluster 1, worker 3, cluster 2, worker 1. So we can see it's being replicated, okay? And one last thing before I break stuff. If we jump into the database and just do a quick check, we can see that I've also got some data. So we'll verify that in a moment when I switch over. So that's just some dummy data I've inserted with some offices and so on. So that's the setup. So let's now trigger a failure. Let's just take a quick look and see if this is all ready to go on the second side. Yep, that all looks good. So I'm running this in a cloud environment. So I'm just going to go ahead and destroy these nodes. Whoops, wait for it to reload. There we go. So I'm just terminating all of the worker nodes in cluster 1, right? So I'm just going to terminate those instances. And they're shutting down. So now if I go back to cluster 1 and try and jump into this Cassandra pod, it's going to fail, right? Because the node is shutting down. So from a Portworx perspective, this cluster is basically failing. Now, how do we now reestablish quorum in Portworx? We do that by manually arbitrating. So I'm just going to deactivate the cluster 1 cluster domain. And then if we query the status, what we should see is that it's marked as not in sync. We'll give it a second just to work through that. There we go. So you can see cluster 1 is now marked as down from a Portworx perspective. So how do we recover the workloads? Well, we have a way of orchestrating that. As I said, we can talk to Kubernetes to do that. We can just call out that. I'm using a CLI here, but we can do this as using YAML objects. I'm just going to activate it on the Cassandra namespace. And you can see we've updated the replicas to the same pod count as the source. That's something that we record as part of replicating the object. And we should see, yep, we can see our pods coming online now, and they're going to mount the correct volumes. So we'll just give that a second to run. There we go. This is a great time for questions, by the way, while we wait 30 seconds.
So Portworx is orchestrating that coming back up again then in the background as part of the cluster function?
Yeah, so when we replicate an object, we're adding an annotation that records the replica count of pods from the source cluster, so that when that activate migration command is carried out, either with a YAML file or a CLI, we can essentially read that value to orchestrate the recovery of the workloads. Yeah.
And you're defining the object in this case as the underlying storage for those pods?
Yes, but also the things that we're deploying into Kubernetes. So deployments, config maps, stateful sets, services. And in some cases, you might not want to replicate something that's specific to that Kubernetes environment, like an OpenShift route, and you can exclude those objects if you don't want to replicate them.
Okay.
I'm just going to quickly jump into this pod and just validate that the data's there. Let's do that. Okay. Classic models. Whoops. There we go. I can still type. There we go. And you can see it's come back in the second site.
Hey, Joe, earlier you said you had some customers that are doing 2-minute RTO. I'm just curious, what are they doing to get to that low time-wise?
Oh, they're using Portworx. No, I mean, so that ability to fire off that single request and have all the pods across potentially all the replicated namespaces come back online is what's helping them achieve that. Right now, if they didn't have that, what would they be doing? Well, they'd be manually redeploying various things, right? All of the various deployments, probably editing them to map through the PVCs through to the underlying storage. And that takes a long time at scale. right? Now, what we're doing is maintaining that relationship so that when you flick that switch, everything comes back in the same state. And that's to give you. That was a great question, by the way, because it teed up my this next slide very well. But that's that's exactly what RBC are doing, right? And they're very public about their use of us to achieve those kind of failover numbers for their Couchbase and MySQL workloads.
Okay. So can I ask a question, Joe?
Yeah, please go ahead.
Just so I make sure I've got this in my head. So what Portworx is a orchestrator of containers orchestration tools, so it can orchestrate other orchestrators to make sure that you can extract any kind of reliance on underlying infrastructure. So giving us kind of full application focused portability. Is that kind of the thing? Am I in the right? Am I at least in the right room?
Yeah, kind of. So I would say I definitely would use the words data orchestration in relation to Portworx. Yeah, for sure. What I would say we're doing is we're sort of enhancing the Kubernetes capabilities for advanced use cases around storage, right? So when customers are running critical stateful workloads at scale, the kind of scenario I just demonstrated to you with, let's say, traditional storage underneath is complex, slow, fragile, operationally painful. Portworx is solving that problem, right? And making it incredibly simple to orchestrate the recovery of large numbers of stateful workloads.
Yeah, okay. I think I've got it.
Yeah, cool.
I'm just about hanging in. You okay?
So I've got a great last slide based on your question. So if you want to read more about this, obviously Gu's gonna jump into this in lots more detail and take you through it from the kind of the CTO perspective. But there are lots of good resources for you guys to get hands on and have a little play with this if it's of interest to you. And also an async demo. So I've shown you sync rep between two clusters, but we have plenty of users who have sort of disparate environments who want to be able to just on a regular schedule kind of sync data. It's a great edge use case as well, especially for retail. And so there's a nice example of that on YouTube as well.